Hi everybody, my name is Laura, and today I'm going to be talking to you about zombie processes in Linux, which is a very fun topic as the name sounds, and a very interesting topic once you get to know it. So first things first, sorry. I'm going to run this coding demonstration on my Vagrant virtual machine, which runs on Ubuntu 14. So first, let's define together what is a process. A process can be thought of as an instance of a program in execution. And I like the word instance because a program can run several times at the same time, and each time a program runs, it's a different process. One way we can know about the ID of the current process is to use the shell internal variable $$. So here, for example, in my shell, I can type echo $$, and it gives me the process ID of the current shell, which is 3144, apparently. Now, one cool thing about processes is that we can fork them. So what happens when we fork a process? Well, it gives us a child process, and the process which is forked from becomes the parent. And we can think of the child process of a process that's running separately or in the background or simultaneously. One way we can do that in the shell is to enter any command or program. So for example, let's try with a very simple pwd, and then enter a single ampersand like this. This will give me another process ID here that you see is different from the parent process ID that I have here. And you can see that it's still running in the background. So if I want to exit from it, I will have to type in Control-C. And there you go, it's done. And it even gives me the name of the command I just ran as a child process. So how does that bring me to zombie processes? Well, it so happens that a zombie process is just a child process which has finished his execution but still has to report to the parent process. So essentially, it's a child process that is still somewhere in the process table. It's done, but it's still hanging. Well, it's not hanging because it's done, but it's still hanging out in the process table. And the funny part is that all child processes at one point in their life have to be zombies before the parent receives their exit signal or status and takes them off the process table. So here I'm going to be demonstrating the use and actually how you can spot zombie processes with a little C program. So let me open a file that we will call zombie.c. There we go. Let's include some standard libraries. So first of all, standard IO for my printing function that I'm going to use. Then I'm going to use unistandard for my forking function, and then finally I'm going to include standard lib, .h for my exit function. We're going to put the program inside the main function directly, and we're not going to take command line arguments. So first things is going to be declaring our variables as usual. So here I'm declaring a PID_T, which is the type in C for the process IDs. And I'm going to call it zombie, because why not? Then our zombie, we're going to actually assign to it the result of the fork system call. The fork system call will create a child process, and it will return the process ID of that child process that will be stored in zombie, the variable zombie. Now let's put a few tests. So let's say if zombie, meaning the result of the fork system call, is 0, that's when I'm going to want to exit my program. So that means that I'm going to make the child process exit. Let's have an else here. That's going to be the parent process. And we're going to print something in that parent process. And we're going to print something like, hello, I am a zombie. and my PID is %d new line, and %d is gonna be the value that is stored in my zombie variable. All right, here we're gonna need to have an infinite loop just so that the program keeps running and gives me time to show you commands in the command line to see where the zombie is on the process table. So let's just have an infinite while loop that sleeps forever, like this, and never forget the return statement because it's a main function. It's our entry point, and there we go. I'm gonna try and compile it over here. So I'm gonna use gcc zombie.c-o for the output, and I want to name it zombie. Perfect, it compiles. So now I'm gonna try and run it. There you go. You can see that it created a child process with its own process ID, and it's looping forever. So it's kind of hanging, which gives me the time to show you the next move, which is going to be identifying my zombie process in my process table. So we're going to use the magic command ps that I like very much because it allows you to print all the current processes in so many ways and with so many different information that you can choose. And that's why I'm going to use AUX for a user-oriented display of that information. And then I'm gonna, if I just do that, it will list all the processes that are currently running in my shell. And I don't want that because it's going to be a very long list, and it's not, for the purpose of this video, it's not very useful. So I want to pipe that command inside a grep command to match a pattern that's going to be composed of capital Z plus and anything, and then it ends with the defunct keyword, like this, and let's see what it gives me. There you go. You can see that grep matched this expression and also this. And the first line is actually going to be my zombie process, and you can see that the status of the process is Z plus, sorry, which means zombie. Yes, because I forgot to mention that the PS actually displays information in columns, and that this column, when I use the AUX flags, is the status. Let me just do a quick demonstration of PS AUX without any piping. There you go, see the big list? Let me scroll all the way up. Oof, that's a long list. There you go. Can you see here? We have the columns for the user, for the PID, then for CPU and memory information. These are things we don't need to understand for this video. And this is stat. Stat is the information that we're looking for. It's the status of the process. So you can see here that most of the process have an S status, right? So these are kind of regular processes. And we don't see our zombie process here. So it's not necessarily listed when I just do ps aux. But when I do ps aux piped into that expression matching command that I just used with grep, we find it. So it is here. And we even see that it's called zombie by the shell. So yeah, it's pretty fun. And now I can exit my program that has been looping forever. And yeah, that's it. I hope I was able to teach you something about zombie processes that I like a lot and that are fun. And I hope you enjoyed this video. Thank you for watching.